Okay, mana udah live lah.
Okay. Hello everyone, welcome back. Whether you are joining us from Paris, Dubai, or anywhere else in the world, thank you for being here. We are live online and we have 2 intense hours ahead of us until 70 Paris time. Today's session, we will talk about optimizing Power BI and Fabric capacities. We will see how to combine Power BI and Azure AI language to analyze unstructured text, feedback, surveys, emails, detect sentiment, and turn it into dashboard to drive real decision. To get us, please welcome Sami Ben Salam, lead BI and Microsoft certified trainer at Diva Team, expert in the Azure data stack, Power BI, and AI-driven analysis. Sami, over to you.
Thank you very much, Serline, and thank you very much to Gora for the presentation. And good afternoon, everyone, and welcome to this new session. So before we begin, I would like to extend a special thank to Gora and the community, and to everyone who is participating in this session, and also to the Azure AI Community Hub for making this session possible and for providing all the logistic part that is related to this presentation and all the sessions we have for those events. We really appreciate this support, this dedication, and this is truly appreciated. So before we start the session, let me briefly introduce myself. So my name is Sami Ben Salem, and I'm lead business intelligence and Microsoft certified trainer. I specialize in the Azure data stack and some technologies, Microsoft technologies related to Power BI, Synapse, Databricks, Spark, Python, and also the AI stack in machine learning. And as a Microsoft certified trainer MCT, I design and deliver also training programs and sessions that can help individuals and teams and companies, organizations to master the Microsoft data and AI ecosystem. So once again, thank you very much for all of you for joining us in this session on mastering Power BI and Microsoft Fabric capacities. And we will tackle today the topics related to performance, governance, security, and scalability. Why is it important to talk about this topic? Because Power BI and Microsoft Fabric, they continue to be adopted across organizations. And in this context, ensuring that analytics platforms should remain performant, scalable, secure, and also well-governed by implementing some techniques and following some strict rules, which is very, very important when especially conducting projects and you are moving to production. So in this session, I will try to explore how capacities impact the performance, the workload distribution, and also the user experience. So you will be at least able to understand if you are facing any issues or any performance issues in the reporting projects or the data engineering project that you are delivering. How can you investigate that, and how can you identify what are the root causes of this kind of behavior? And of course, we will discuss the differences or the main differences between two main different types of capacities, including shared capacity and dedicated capacity. We will also review the best practices to optimize the semantic model and the refresh operations, and also learn how to monitor and manage the capacity health. So, of course, we will cover also how to work with workspace management, role-based access control, security, and access management. So those are the main topics that we will try to cover during this session. Of course, the time is very limited, so we wouldn't be able to go through all the, let's say, the details that are related to those topics. But this can be first session to introduce the subject, to introduce the problem, the context, and in the upcoming sessions, in upcoming events, maybe we can go deeper into the details for each topic separately. For the agenda, I propose to cover 8 topics, or key, let's say 8 elements. So here you have the roadmap of the session. And of course, I try to deliberately order the sessions, order each topic to be built on the one before it. So by the end, you will have a complete mental model of how Power BI and Fabric capacity work and how to run them correctly. So first, we will start with the foundations. So first, we will start with what is exactly a capacity. So the definition of Fabric capacity, which is the pool of compute and the memory behind everything you do, and all the processing part of the project. Then we will look at the 2 ways it is provisioned. So through the shared capacity, where you run an infrastructure Microsoft, which is managed by Microsoft across many tenants. And the second type of capacity, which is dedicated capacity. And here we will talk about this in details to present this topic and to define what is dedicated capacity. From there, we will zoom out to the capacity architecture. So how all those pieces fit together. How can we present a complete architecture related to Fabric capacity? And how can we arrange the different items that may fit or can be used when you create or design a capacity with Fabric. Then we will move to the engine to see how capacity resources are actually consumed. And of course, those capacity that are measured in what we call capacity units. So we will, of course, talk about this point later in the session. And this will naturally lead us into the capacity planning and resource allocation, how to size and distribute the capacity to match the real demand that you may have. And we will finish with scaling and the life cycle management, how you grow, how you pose your capacity, how you manage capacities over time to stay both fast and cost efficient. So those are the 2 main, let's say, targets that we need to keep in mind to reduce the cost and also to be efficient and to have speed. So let's start with the first topic, which is the capacity, and we will start by defining capacity. What do we mean by capacity? So in simple terms, the capacity is a dedicated set of compute and memory resources that powers your Power BI and Microsoft Fabric workloads. So it is the engine that runs your reports, refreshes when you want to refresh your semantic model, when you want to execute any type of queries, when you want to access those reports to interact with the different visuals that you have on the report. All those computations or operations need to be executed, and to do that, we need to have a compute capacity and memory. And all of this is available within the capacity that we have in Fabric. So everything your users, they will experience, including the speed, including the reliability, the responsiveness too, everything, there is a capacity behind it. So to make it more concrete, technically, the capacity is a reserved, let's say, named pool of resources that is measured in what we call a capacity unit. So for those capacity unit, when you will provision Fabric capacity, you will choose what we call the SKU. So the stock keeping unit. So for example, F2, F4, F64. So depending on the size you want to get, or the capacity of the computation you want to get, and of course, depending on what you have in your system. And that SKU, it determines how many capacity units you have available to execute all those computations and all those operations. And of course, those capacity units, they translate as we mentioned, into the CPU and the memory that back every operation on the platform. So the SKU you pick is in fact the size of your engine. The capacity is also a boundary. So it defines a union of governance and isolation. So workspaces, for example, are assigned to capacity. So here, this is the first level of definition. You have the capacity, and then you can define different or multiple workspaces within the capacity. And of course, then you will add some content. You will add some items. For example, you will add reports, you will add data sets. You may also add data flows, pipelines, notebooks, lakehouses, warehouses. So all those items that you can add to your capacity will reside within a specific workspace. And of course, all those items, they will consume the computational power from the same shared pool that you have on that capacity. So this is what makes the capacity such a powerful concept, because it lets your group or it lets your group related, let's say, workloads together, give them dedicated resources to be executed properly, and also manage them as a single billable unit. So you will have only one bill for the whole capacity and for all the items that you have within that capacity. So for example, we can consider that for a retail company that is running its sales analytics on, let's say, an F64 capacity. So every weekday, for example, at 7 a.m., 100 store managers, they open their dashboards at the same time. And at the very same moment, a large semantic model kicks off its morning refresh. So we have here two operations: the users who are accessing the reports, and also you have the refresh operation that is executed on many semantic models that you have within the workspaces. So, of course, this refresh operation is executed to pull the yesterday's transactions. So all of that, the 100 concurrent queries and the heavy refresh, all this draws from the same pool of capacity units. And thanks to what we call bursting or scaling that you have within Fabric, Fabric is able to absorb that morning spike, the refresh completes, and the dashboards stay responsive. So we can provide, or Fabric can provide, as much power as necessary. So now you can picture the same company launching a big seasonal sale. So for example, you will have a sudden peak or increase in the data volume for that specific period or for that specific, let's say, month in the year. So here, in this case, refresh will run several times a day, and twice as many users are connected. So since we have a peak in the usage of the reports, so the capacity is now consistently maxed out. So the reports will start to load slowly and the refresh will queue up. And here, this is what becomes problematic. So the team has two choices in this case: whether we can optimize the workload, for example, by making, for example, the semantic model lighter, or scheduling the refresh more intelligently, or scale up to a larger SKU, like, for example, F128 or F128, to add more capacity units. So that single scenario captures the essence of the capacity management, which is a shared finite engine that you must size, that you must optimize and monitor so it keeps up with real-world demand or real-world demand. So in this case, as we mentioned, you have that capacity, you have a specific, let's say, resources to be run on the capacity, some operations to be executed, and at the end, it's up to the user or to the team or to the BI team to manage and to allocate those resources efficiently. Two types of capacity can be proposed. So here you have, we will talk about the first type, which is the shared capacity. So the shared capacity, this is where most organizations begin their Power BI journey. So it's worth, for example, understanding exactly what is and where it fits, since it is the first option that can be suggested or proposed for organizations. With shared capacity, The resources are entirely Microsoft managed. You don't provision, you don't maintain anything yourself as a company or as an organization. Those resources are shared among multiple tenants. So organizations also use. So you are not the only one who is using the capacity and taking profit or using the computational power that we have within the capacity. And the advantage is that with that capacity, you also have a Power BI Pro licenses already provided. So there is no separate capacity to purchase for creating or to create the reports and to publish that to the Power BI service. And the trade-off here is that there are no dedicated performance guarantees. So because you are not drawing from a common pool, for that reason, shared capacity is best suited for small and medium organizations whose workloads are modest or predictable. Keep in mind that with shared capacity, you are not the only one who is using the capacity. It is allocated to multiple tenants in multiple organizations. So where does this make the most sense? Shared capacity is team consumes a handful of reports, for example. It also works well for small business intelligence projects that don't really care, let's say, carry heavy data volumes or large audiences. So we don't have a lot of interactions on the reports or a lot of data to be refreshed or to be managed every time you use the report. And it is also ideal for development environments where, for example, you can or you are building or testing before promoting content to production and before pushing that to production. And it is also perfect or perfectly suited to individual analysts who simply need to publish and share their work with that managing infrastructure. So once again, everything is shared by Microsoft. You just need to connect to put your reports in the capacity and to start interacting with results. So to make it short, the shared capacity, sorry, gives you simple is a starting point. So you need to think of the scaling capabilities or capacity that you may have when you start deploying more and more workloads on the system. So the moment your performance needs become more demanding or you require guaranteed resources and advanced features, that's when you start looking at dedicated capacity, which is exactly where we are heading next. So for dedicated capacity, the idea is that this is where you especially to have more power to serve the different workloads and items you have in your capacity. With dedicated capacity, you get a reserved pool of resources. So it is no longer shared with other users. You have that capacity that is reserved only for you. It is provisioned exclusively for your organization. So you are no longer sharing compute with other tenants. It is licensed at the capacity level, so through the Power BI Premium or Fabric capacities, such as the FSKU capacities rather than per user, which means that you don't have specific licenses for each user, but you have them for all the users that you have within the organization. You get predictable, guaranteed performance, even as many workloads as you have more capacity and more power on executing the operations and interacting with the reports that you have. With this kind of capacity, with the dedicated capacity, you also unlock work with larger semantic models to also AI workloads. And of course, the Fabric experiences with all the items that we have within Microsoft Fabric. And for that reason, dedicated capacity is best suited for large enterprise and mission-critical analytics. So this is the right choice for the enterprise-wide reporting. We're not talking about for the enterprise-wide reporting purposes, where thousands of users consume content concurrently, consistent, reliable performance with a clear service level expectations. It suits also large or complex semantic models that exceed the limit of the shared capacity. And it is the foundation for production environment governance. You can have scalability and also advanced Fabric workloads, including, for example, direct lake, data engineering. So here, this can be the perfect choice. Large volume of data and many users that are interacting with the reports that are published. For the capacity architecture, the idea here is to show you kind of architecture that we can suggest, that we have with Microsoft Fabric, the different elements that you have. Of course, for this architecture, I'm not going deep into the details. I will just show you the different blocks that we can have in this architecture, but more details will be added to the LinkedIn newsletter that I will publish just after the session. I will share with you to provide all the details. So don't hesitate to connect and to stay tuned with the newsletter. So here, for this diagram or for this architecture diagram, we try to understand how a Microsoft Fabric capacity works from an architectural perspective. We start with the left, or we start from on the left. So you have the different data sources that you may have. So for example, they can be cloud applications, on-prem databases, streaming platforms, IoT devices, external APIs also. Regardless of where the data comes from, everything is ingested into Microsoft Fabric or into the workload that will be executed by the capacity. At the center of the architecture, you have the Microsoft Fabric capacity. So this is the compute engine that powers every Fabric experience. Instead of allocating resources separately for each service, this is what we used to do before we have Microsoft Fabric. Fabric provides a shared pool of CPU, memory, storage, and compute units. All those elements are available in the same platform, are located in the same position, or let's say in the same location. And of course, all the workloads that you will have within that platform will consume these same, let's say, features or resources that are available within the capacity. Inside this capacity, you may have multiple Fabric experiences, including data factory, data engineering, data warehouse, data science, real-time intelligence, Power BI, Microsoft Purview, OneLake. So all those items and services share the same compute resources. They can compete with each other if the capacity is not properly managed. So that's why it is important to pay attention to those elements. For OneLake, it serves as the unified storage layer within that capacity. So it allows all Fabric experiences to access the same data without unnecessary duplication. So this is very good advantage, or very big advantage, because you will have only one unique, let's say, source of truth. You don't need to duplicate the data from one workload to another. you will have one, let's say, snapshot of the data that will be accessed by all the workloads that you have. And of course, this will simplify the data management and also improve the collaboration across the different teams that we may have within the project, including data analysts, including data engineers, data scientists, and all the other, let's say, profiles that may exist when working on the project. Next, the last level, or on the right, you will have the conception layer. And here, you will have the business users. You will have the analysts. You will also have the data scientists and administrators that will access the reports, that will also access the semantic model when necessary. They will access the dashboard. They will use and create notebooks and other Fabric artifacts. And their experience directly depends on the health and performance of the underlying capacity. So if we have more users, if we have more data to be managed, to be processed, of course, here you need to move to a higher capacity or to scale to more performance. Then at the end, you have in the bottom, you have the governance layer. This is where organizations implement security, implement role-based access control, workspace management, monitoring, compliance policies, cost optimization. And in this case, governance will ensure that the platform remains secure, scalable, and efficient. And you see that this type of operations are executed on the whole platform. It is not dedicated to a specific step or to a specific, let's say, area, but it spreads for all the platform that you have here. So here, the key takeaway from this architecture is that the capacity is the foundation of Microsoft Fabric, that every workload, whether it is refreshing a semantic model, running Spark notebook, executing a data pipeline, opening a Power BI report, each step or each operation consumes the same shared compute resources from the capacity. That's why understanding capacity management is essential for delivering high performance and strong governance and scalable analytics platform. So this is very, very important. Okay, we move to the next slide where we will compare between shared and dedicated capacity. And in this case, we will have to, or we can compare on 4 key elements. The first is in terms of resources. Shared capacity draws from a common Microsoft managed pool that is used by many tenants. While dedicated capacity, it gives you a reserved pool that belongs to your organization alone. So you don't need to, or you don't have to move to anything else or to do anything else. So it is just based on the elements that you have within the organization. Next, the second element that we can compare is in terms of performance. So in terms of performance, shared capacity, it offers no guarantees and can be affected by other workloads. Okay, so since we are connected, or since you are sharing that with other tenants, with other organizations, so of course, there is no guarantee in terms of performance. But for dedicated capacity, it delivers predictable, consistent performance even under load, because in this case, you will have those resources that are dedicated to you, that are reserved to your activity and to your organization. So you don't need to share it with other users. You will have all the elements that are necessary to you to use and to work with. In terms of licensing, with the shared capacity, it comes included with the Power BI Pro per user licenses. While for a dedicated capacity, it is licensed at the capacity level through the premium license that you have. So this is not individual. This is for the entire organization. As long as you have the credentials to connect, or the professional credentials to connect to your organization, you can take profit from the use of the capacity and the use of the license. Then you have in terms of capabilities. So for the capabilities, dedicated capacity, it unlocks larger models. So you will have more capacity, higher refresh frequencies. So you'll be able to refresh your semantic model more frequently. You will also have XML endpoints, which means that you can connect to the capacity or to the items that you have within the capacity from external resources or tools. And it also provides the full range of Fabric workloads that shared capacity simply doesn't provide. So here, as you mentioned, you have more resources, you have a better performance, you have a good licensing, let's say, plan, and you have more capabilities. So the question here is how to decide which, let's say, solution to take. Is it interesting to go with the shared capacity or with the dedicated capacity? So here, the trade-off, it really comes down to cost versus control. We can say that. Shared capacity is simple. It is economical too. And it is perfect when your workloads are modest. And when also the audience is small. So if you have a limited number of users that can access those Power BI reports, or that can execute some, let's say, workloads or data flows on the Microsoft Fabric, or they can access lake houses or reduce, let's say, resources for the lake houses, the shared capacity can be a good solution. And of course, you don't need to have any guarantees. You are not in a production mode. You are just testing. You are just developing. For dedicated capacity, it costs more and asks you to size and manage it very good. So you need to master that operation. You need to know how to manage, how to optimize, how to tune the capacity in order to take profit from all the resources that you have and all the computational size that you have within the capacity. But it return you, but in return you get the performance. It is more expensive, but you have a higher performance or a better performance that you don't have with shared capacity. The same for the scale. It can scale easily. You can do it directly on the portal without losing any time. So if you think that you need to move from one capacity level to another, you can do it directly on the portal. And of course, you may have, or you may take profit from those advanced features that enterprise and mission critical analytics demand or ask for, let's say, faster execution and higher capabilities. So this is the same difference, or the main difference, sorry, between shared capacity and a dedicated capacity that you have within Fabric, and how to decide for which type of solution you can, or which type of solution you can select. Okay. How are capacity resources consumed? So this will be the next step, or the next, let's say, topic to discuss and to answer this question. Of course, since you have selected the type of capacity you want to take, let's see within the engine how does it work, how the capacity resources, how they are consumed, how they are allocated, how they are managed. So this is very important because it helps to think about consumption that you have within the capacity. And here we talk about mainly two categories. You may have interactive operations, or you can have interactive operations within the capacity. So this is the type of operations or workloads that you may have. So in here, anything users trigger in real time. This is what we call the interactive operations, especially when opening a report, when interacting with the visuals, when selecting the filters, when running a DAX query, for example, and also using the Q&A visual. In those cases, you are interacting with those items, you are interacting with the report, and here, this should be instant. The latency should be very, very limited, because when you want to access a specific report, you need to get the result at the time of the access. You may, for example, tolerate 2 or 3 seconds of delay, but of course, the goal is to reduce that time or that latency time to the maximum. The second type of operation is what we call background operations. So we have the interactive operations mainly related to the users when they interact with the reports that you have on the capacity. Then you have the background operations. And in this case, this represents all the work that runs behind the scenes, including, for example, the scheduled refreshes, the execution of the data flows, the pipelines that you have created and that are executed, let's say, on a specific, let's say, basis. For example, when you schedule those pipelines, the batch or the jobs that are executed also. So since you can create those jobs by Spark or any type of industrialization operations that you can have. So both categories, they pull the capacity to execute those operations from the same capacity, okay? So whether it is interactive operations or background operations, you will take the capacity or the computational capacity from the same location or from the same element, which is the capacity that you have within Fabric. But they behave differently and have different tolerance for delay. So as we mentioned, if you are interacting with the report, so for example, for the refresh, we may delay it. For example, when I will connect, for example, if I define the refresh to be executed at 7 a.m., and I know that my team starts working at 9 p.m., I have 2 hours of delay that is possible to have. So the goal is that when the team will connect to the capacity, when the team will connect to the report, they should have the data. How long it takes to be executed, I don't care. The only advantage or the only problem is that when I will connect, I want to have the data. The problem with the interactive operation is that when I click on a filter, I want to get instantly, I want to get the result. And as I said, this is different when it depends from one category or another category. And of course, as we already mentioned in the previous slides, all of this is measured in a single unit called capacity unit or CUs. So you can think of those CUs, for example, like the fuel in a tank. Every action, for example, opening a report, running a query, refreshing the data set, it burns a little fuel. In behavior, actions burn more. Okay, so if you have more workloads or more, let's say, operations to execute with more data, they will burn more, let's say, fuel. Your SKU, so which is the selection that you do on the capacity first, simply sets the size of the tank. This is where smoothing and bursting help when we have with Microsoft. So imagine, for example, you have a scheduled refresh that suddenly needs more fuel than your tank normally loads. So as we said, it can be associated with a peak in a specific period or a specific day. For example, let's say during the summer, you will have special offers for the users. So you will have, let's say, more purchases on the system or on the e-commerce platform. So you will have a peak for the users accessing the platform to connect. So in this case, instead of scaling Fabric lets it briefly borrow extra capacity or extra, let's say, computational power, and then spreads that cost out over the next few minutes. So, for example, 1 minute refresh that you can have for the semantic model might spike well above your limit for a moment. So Fabric, as we said, smooths it out afterward. So the colleagues opening their reports at the same time, they will never notice that delay, or they will notice a thing. So this is how the capacity resources are consumed and are executed for the capacity. Next, we have the capacity planning resources. So now that we understand how capacity is consumed, we can turn that understanding into a plan. So this is where the capacity planning and resources allocation come in. And it is really about answering one question: how do we make sure the right workloads get the right resources at the right time without overspending? This is a really critical operation, and of course, it's not easy when you will start first using the capacity or interacting with the capacity or making the capacity available for other users. But this is a very important step. In fact, good planning starts with knowing your demand. So before you size anything, look at how many people use your report. This is the first information you start with, or you need to start with. When they use them, this is also an important information. So how many users, when they use the reports or their workloads, and how heavy your refreshes and queries really are, because this will start, or this will design the strategy, or let's say the plan that you will execute or you will set for optimizing the capacity of your Microsoft Fabric. So a capacity that serves, for example, 50 analysts during business hours has a very different profile from another capacity running hundreds of embedded users around the clock. So the Fabric Capacity Metrics app here is very important, or will be your, let's say, best friend here. It will show you, so this is an application dedicated to monitoring the performance, to know and to understand exactly what is allocated to which item and how the capacity is consumed by the different workloads and the users. And of course, in this case, for this application, it will show you, as we mentioned, exactly where your capacity unit are going, which items are the most expensive, and when you approach the limits that you have with that capacity. From there, it's about just matching the SKU to that demand. So the goal isn't to buy the biggest capacity you can. So when you start your work, or when you start your activity, it's to right size. Okay, we can say that. Pick the SKU that comfortably handles your normal load, that leans on smoothing and bursting to absorb the occasional spike, and leaves a sensible margin for growth. So those are the main recommendations that we can have for those who are, or for those who want to use those capacities. So first, don't start with the biggest. Don't think about the biggest capacity since the beginning, because it can be very expensive when you start with that. Three main informational questions you need to ask: how many, let's say, people are using the reports? When do they use those reports? And what are the refreshes, or the refresh operations that I need to apply and need to execute on my capacity? You can also think about the size of the semantic model you have, how to optimize the report, how to optimize the semantic model. So the DAX functions, those are also recommendations associated to Power BI itself, not necessarily to the capacity. This is done on the Power BI tool, on the Power BI desktop, to optimize the performance. But in terms of capacity, we are talking about, we already have the item that is already optimized. How can we do more optimizations in this context. What else to say in this? And of course, then after defining all those elements, then comes the allocation. So here, this is when you decide how to distribute that capacity across the different workspaces in the teams that are connected to your capacity. A common pattern is to separate the workloads by priority, for example. So you can keep your business critical interactive reporting on one capacity, and you can push heavy background jobs or big refreshes, data flows, and pipelines into another capacity. So you can use both or two capacities depending on the criticality of the workloads that you have. So at least you dedicate, let's say, a specific capacity for a specific type of applications. Of course, another recommendation is that, for example, for the scheduled operations, you can schedule them or execute them for off-peak hours. So before starting the work, you can execute the refresh operations out working hours or outside working hours. That way, you can, let's say, have good performance, or you can optimize the performance of the model and of the capacity. Sorry, and if you have any issues, you can distribute the capacity on different, let's say, segments depending on the application and the use cases you may have. The last topic here is the capacity scaling and the life cycle management. A capacity is never a set it and forget it decision. So we take the capacity, we create the workloads, the items, we publish the reports, we share them, and it's okay. No, this is not the good approach to have. Your business changes. You will have more users that will be connected, or they need to connect to the capacity. You may have new workloads. You may have busy seasons. You will have peaks during those specific periods. So here, when we talk about capacity scaling and lifecycle management, this is something that you need to, let's say, monitor when you are working on the capacity, because this is how you can scale, how you can pause. This is where you manage your capacities over time to stay or to keep them, as we mentioned in the first slide, efficient, so fast and cost efficient. So for example, in terms of scaling, so there are two ways to grow. You can scale up, which means that you are moving to a larger capacity or to a larger SKU. So going from, for example, an F32 to an F64. So for example, when your steady state demand has simply outgrown what you have. So scaling is one solution that you may implement. Going with bigger capacity, having more capacity units to feed the requirements. The second type of scaling is the scaling out, which means that you can spread the workloads across multiple capacities, or let's say reduced capacities with reduced computational power, so that no single one becomes a bottleneck. So the good news with Fabric is that scaling is fast. Okay, so as we mentioned, you just need to go to the portal to buy or to scale to a higher capacity or to get a new capacity. So everything will be provisioned in minutes. You will have your capacity and you can switch to it. Where Fabric really helps you or helps saving money is the ability to pause and resume. So pausing and resuming is also very important, because with Fabric capacities, they are billed by second, which means that if you have, for example, workloads that only run during business hours or during development, or you have, for example, a development capacity, that nobody touches at night and during the weekends, you can pause it and stop paying for compute entirely. You can then resume the capacity instantly when it's needed again. So when you start the week on Monday morning, you can restart the capacity and you can pause it or stop it on Friday, for example, let's say at 7, 8 p.m. So depending on the activity you may have. So in that case, Sunday and Saturday will not be billed for you for the use of the capacity. And of course, for predictable production workloads, reserved pricing gives you meaningful discount over pay as you go. So this is also an alternative. And the pattern is simple. So pay as you go with post for bursty or non-production work, and reservations for steady production. So this is how you can implement or you can use your capacity and the strategy that you can set up. Let's give an example for this. So to make things better for understanding. Imagine that you have a development capacity that's only used about 40 hours a week. So if you leave it running all the time, you pay for 168 hours. If you automate a pause and resume schedule around your working hours, you pay for roughly a quarter of that for the exact same work, okay? Because it is not used outside work hours. That's the kind of saving good life cycle management will help you to unlock. And you can, of course, automate it entirely with the API or with PowerShell, so no one has to remember to flip the switch. And of course, you need to tie everything to monitoring. So monitoring is a very important component that you need to add to all the operations you execute. You can use, as we mentioned, the capacity metrics app to decide when to scale up, when you can safely scale down, and also when the capacity is sitting ideal and should be paused. So treat scaling and lifecycle management as an ongoing rhythm. You need to review, you need to adjust, automate, and of course your capacity stays right sizes as you need to evolve. So this is very important. The two last sections, the capacity planning and the resource allocation, and the capacity scaling and lifecycle management, because they give you, let's say, proficiency on how to use those capacities and how to implement them. Okay. So since for this session, I haven't planned to a demo, but of course we can do it in the upcoming sessions. I wanted to share with you some real-world use cases to discuss about the best practices that we can implement if you want to fine-tune or to optimize the performance of the capacity. Three main use cases or real-world scenarios that illustrate how capacity optimizations techniques go far beyond simply processing larger or a higher fabric capacity. So this shouldn't be the first solution that you need to go with. So in those use cases, the objective is the same: deliver fast, reliable, and scalable analytics, and at the same time, you keep controlling the infrastructure costs and also remain a great user experience, or maintain, sorry, a great user experience. Use case one. You have an executive dashboard with slow performance. So here, for example, in this first scenario, as mentioned in the slide, you have a global retail company where more than 1,500 executives access the same Power BI dashboard every morning. During peak business hours, report performance degrades significantly. So because we have all those users coming to the report, pages may take several seconds to load, sometimes several minutes, and users experience delays. Okay, and in this case, also the CPU utilization and the capacity reaches its limits. So if you are no longer able to refresh your dashboards or your reports, you also reach the capacity limit of the capacity. The investigation reveals several issues in this case. So first, the semantic model is very large. There are too many visuals on the same report page. Also, this is another issue or problem when you are designing your report. DAX calculations are overly complex. And you also have hundreds of users that are querying the data set at the same time. So those are the issues that have been identified after investigation. Instead of immediately increasing the capacity size, the organization here will first try to optimize the semantic model by implementing a proper star schema. So they have reviewed the semantic model and they have noticed that we can implement a star schema and we need to do that to optimize the performance. They will also remove in-used columns. So if we have any in-used items within the semantic model, they should be removed, especially calculated columns that you add in the Power BI desktop. We also need to review the DAX formulas or the DAX measures to simplify the calculations by using the variables, for example, by using more optimized DAX functions, and so on. And we can also implement the incremental refresh in order to only get the new data that is inserted into the database or into the data source. So no need to load every time the whole and the full package or the full data that we have in the data sources. And another technique is to use aggregation tables. Instead of computing every time, using aggregation tables will help you having the data aggregated in a specific manner to be always queried rapidly. So those are the operations that we can execute and that are related to the Power BI model or the Power BI solution itself. We can also execute other operations related to the data set that we have in the capacity. Data set refreshes are also moved outside business hours. This is also recommendation and best practice. So you need to refresh the data set outside the business hours. So whether in the morning before starting the work or at the end of the day after finishing the work. This will reduce the competition between the refresh operation and the interactive queries. Just keep in mind that every interaction that you have with the report. So here, for example, we have one report with multiple pages, 1,500 users. So you may expect to have a very high number of interactions of the report. So adding to this, and of course, those operations will consume capacity units. Adding to this, the refresh operation that should be executed, this will, let's say, decrease the response time and will impact the performance. So when you execute this operation, you will see that you have a much faster dashboard with lower CPU utilization and significantly better experience for all the business users. And of course, you will monitor that using, as we mentioned, so the capacity metrics app to see exactly what have changed compared to the previous version. So here the lesson is that taking the decision to remove to a higher capacity or to scale to a higher capacity shouldn't be always the first solution. So for cost optimization and to reduce the amount of or the money to be spent on the solution, this shouldn't always be this shouldn't always be the first, let's say, way that you can implement or use or set up to optimize the performance. First, think of model optimization that usually delivers the biggest performance gains, and start with the model optimization and the report optimization before you scale to another capacity. Use case one, a manufacturing IoT analytics platform. So second example here for a manufacturing company. So every day you have millions of IoT sensor records that are collected from production equipment. And at the same time, production managers that are monitoring the live dashboards while data engineers execute Spark notebooks and data factory pipelines. Here, the challenge is that you have millions of records that are collected from IoT devices. You also have managers they want to access the report and to visualize the data. You also have data engineers that work with Spark notebooks and data factory pipelines. So 4 items or 4 elements that require having the capacity or computational power to execute them. In this case, the challenge is not only in the report itself, because we don't have only the report. It's different from the first use case. But the fact here is that multiple workloads are competing for the same capacity resources. You have the interactive Power BI report, you have the Spark jobs, you have the semantic model refresh, you have the data pipeline. All those operations, they are all sharing the same CPU and memory. And to optimize the performance, in this case, the company can separate the interactive and background workloads. So this is also a very efficient solution. You can separate, as we mentioned, interactive operations and background operations, including, for example, the data pipelines, the refresh operations, the jobs. They can also schedule those heavy processing during off-peak hours, outside working hours, and using also the direct lake for large data sets connection. They can also isolate critical workloads whenever necessary. So this is also very important. Don't forget to keep continuous monitoring through the capacity metrics application, which also help the administrators quickly identify the bottlenecks that you have within the system before users notice the performance degradation. So at least you can expect and you can, let's say, predict the different issues that you may have with the capacity. The second use case, we will have an enterprise business intelligence platform. And for this platform, this is provided for a large multinational organization. So over several years, different business units, they have created hundreds of workspaces, thousands of reports, and hundreds of semantic models that exist in the capacity and also in the workspaces. Of course, the platform continues to grow. Governance has become increasingly difficult. So managing all those resources and items we have. Many semantic models, they can be duplicated, they can be unused. Also for the reports too, you may have reports that are published and they are consuming data sets, but no one is using them, no one is viewing or accessing those reports, but they still continue consuming resources. You also have some refresh schedules that overlap, and this is also very important. So the idea is not just to move those refresh operations outside working hour, but also to check and to verify that they are not overlapping. And of course, in this case, instead of purchasing additional capacity, we can start by improving the governance. How to do that? First, for duplicate semantic models, they should be consolidated. Unused reports should be deleted, okay, or removed from the workspace. You need to optimize the refresh schedules outside working hours and checking that they shouldn't overlap on the same capacity. Standardize also the workspace governance to define the users who should access to which type of operation, and also the role-based access control that should be implemented across the platform. So for example, you don't have users that come and connect to different workspaces that are not allowed to access to, because if they have access to those reports, they will interact with those reports and we will have additional, let's say, operations. So for those actions, they will reduce the infrastructure cost because you are not moving to another capacity. They will improve the security because you have set role-based security and you have defined who should access to which type of resource. They simplify the administration, and also they make the platform much easier to scale. So in this case, it is very important to notice that for this scenario, we highlight that governance is also a performance optimization strategy that you can implement, that you should implement and take into consideration when you are working with the capacity. So across these three examples, we can identify a common pattern. High-performing Power BI and Microsoft Fabric environments are not built by simply increasing the compute resources. So this can be a solution, but of course here you need to estimate the cost that will come with that decision. They rely on well-designed semantic models. So if you want, of course, if you want to increase the performance, we need to pay attention and to check the design of the semantic models. We need to optimize the workloads. We need to be or to rely on proactive capacity monitoring by using the capacity matrix application. To think of an effective governance and intelligent capacity planning, because those are the key elements that will help you using the capacity efficiently, having a reliable, let's say, solution for the different teams that are on the different projects using the capacity, and to provide the end users with a very good solution or a reporting solution. And this is exactly, of course, the mindset that we should adopt when managing enterprise scale Power BI in Microsoft Fabric environments. A lot of things or a lot of operations to do, not just having to move from one capacity or to scale from one capacity to another. Okay. So that was the last slide for this session, and I hope that the subject that we have discussed was interesting, and that I have provided you with the details related to how to optimize the performance of your capacity, and in which case you can or you need to go for different solutions than scaling the capacity or moving to a higher capacity units. So thank you very much for all of you for this session, and I don't know if you have any questions. Of course, all the details related to this session, I will publish them on the LinkedIn newsletter that will be available for next week, and I will provide more details.
And you can drop the question in the chat.
Yes. I don't see any question in the chat.
Well, thank you, Seme, and thank you everyone to join. See you at the next one.
Thank you very much.
Thank you.
Thank you for all of you.
And it was a great session, and also a very topic that is today is very interesting, but also up to date. Without data and Power BI, that will be that should address a lot of people in the tech. So I think that it's very, but I have one question I would like to ask you. In fact, it is what happened if the capacity is overloaded or heavy demand.
Yes.
I would ask if the solution will automatically scale down or scale up.
Okay, so for the question you are asking, if we have a heavy demand, how this will be executed, or how the capacity will behave?
Yes.
Okay, yes. So first, let's say that when you will purchase the capacity, we know that you have a maximum, let's say, resources that are allocated to the capacity. But when we use them, it's like the accelerator that you have within the car. So when you accelerate, the speed will increase. So it is exactly the same thing that we have with the capacity. Let's say, for example, that you have some users that are using the capacity, but you are not reaching, let's say, the limit. So everything is good. So you don't have any issues, you don't have any problems. You have a limit that you didn't reach yet. And the users are very happy. They are satisfied with the solution. When they interact with the report, everything is smooth, everything is good. So we don't have any issues or any problems. But generally, in the company or the organization, we have more semantic models that are published. We have more Power BI reports that are created. We have more users that are, or they come to connect and to use the report. In this case, the resources are allocated depending on the requests or depending on the operation that are executed. Of course, if we need to use, let's say, 80% of the capacity units that are available, the capacity will scale automatically with Power BI, with Fabric, that it will scale automatically until reaching the limit. And if we have less demand on the computational power, it will decrease. So this operation of scaling is executed automatically by Microsoft Fabric. So you don't need to manage that or to define or to tune that. Depending on what you have within your system, what the users are asking in terms of capacity units, Power BI is Microsoft Fabric with the capacity is able to scale up and scale down. The problem comes when you reach the limit. If you reach the limit, this is when we talk about the solutions that should be presented or that should be discussed, because sometimes, as we mentioned, sometimes it can be just a governance problem. So you have many semantic models that have been published in the capacity. They are not used. Okay, for example, the teams that have created those reports, they are moving or they have left the company, but they didn't delete those semantic models. And those systems, they keep refreshing every day, but no one is using them behind. So this is a governance problem or governance solution. So we need to investigate to identify what are the models that are available or the semantic models that are available that are not in use, and to delete them. So always think about different ways of optimization, not only going to buy new capacity. I don't know, Gora, if I asked you a question.
Okay, yes. Okay, thank you. Thank you very much. It is now very clear for me. I think
Thank you.
that is very interesting. So thank you
Thank
for
you very
the
much.
whole session.
Good. So thank you very much, Gora, and thank you very much, Sele, for all of you and for the community. That was a great pleasure for me to deliver the session today. And of course, in the upcoming sessions, maybe you can go for demo. I know it can be very interesting to see how to use the capacity metrics application, for example, to see how we can monitor the capacity that we have and to detect those bottlenecks that we have within the capacity. Thank you very much for all of you, and have a nice week. Thank you.
Okay, thank you.
Thank you, Salam. Goodbye.
Thank you very much. Thank you. Bye.
dama nekk ci benn conférence mais jeex na